Okay, so I start. My name is Martin Johns, University of Hamburg, and I think this is one of the few web security talks here at this conference. So I will talk about CSRF, Cross Site Request Forgery. And I, hopefully, if my laptop lets me, or maybe not. So I seem to have the same problems as Jeff Moss said. A very short introduction to the www. So in the very beginning, the www was one protocol and one specification for documents. We had HTTP and HTML. And HTTP is hypertext transport protocol, and HTML is hypertext markup language. And the interesting words here are hypertext. So if you look at the beginning of the www, you will notice that this, what we call today the internet or the www, was cross-domain by nature, because the hypertext nature, and especially the linking between documents that were hosted by different people and the intermixing of content from different people, was a very essential design goal of the www. And then you all have been there. We had innovations in this, and a lot of innovations. We started to have really full web applications that allowed you to do banking or email. And so you need authentication. So because HTTP has no session management, they invited their own session management. We have authentication tracking, and we have client-side technologies like JavaScript. And while this innovation happened, the people that did the innovation somewhat, not totally, but they somewhat forgot that the internet or the www was about cross-domain interaction. And so this is one of the reasons that causes the problems I will talk about today. Another brief introduction, only 3 slides. I will talk a little bit about browser security. And as there's not much security in browsers, we only need like 3 slides to do this. Because if you look at security features in web browsers, you will notice there's one single policy or rule that governs all the security features of web applications. And this is called the same origin policy. There isn't anything else. So the only security policy we have in web browsers is the same origin policy. As the same origin policy was designed to restrict the capabilities of client-side technologies like JavaScript, Java, Flash, and it's rather simple. We look at 2 elements that are displayed in our web page or that are run in our web page or in our browser. And if these 2 elements share the same origin, which is defined by the protocol, the domain, and the port. So example, HTTP is the protocol, www example org is the domain, and port 80 is the port. If these 3 entities or these 3 values match, the same origin policy is satisfied. And the 2 elements that we look at, so the client-side script and something else, they are allowed to interact with each other. The same origin policy pretty much affects everything. It affects JavaScript, affects Java, it affects Flash. Cookies are sent according to the same origin policy. Pretty much everything we know nowadays in web browsers is to some degree dependent on the same origin policy. So if you look at that, with protocol, domain, and port, the same origin policy actually defines a rather nice sandbox. So we have no direct access to the file system because the file system is accessed by the file meta protocol, while our web pages are accessed by HTTP, so the protocol rule matches here. There's no direct access to other hosts because of the domain property, and there's even no direct access to other applications that run on the same host because of the port policy. So the same origin policy should restrict the applications or JavaScripts of applications to their own web application, shouldn't it? Not completely. There is a loophole in the same origin policy, and the loophole dates back from the very, very beginning of HTTP and HTML. So we have a couple of elements in HTML that implicitly cause HTTP requests. Image, style, script, iframe. Those are all tags that reference external entities, and so if the rendering engine of the web browser encounters those entities, the web browser causes another HTTP request. So if JavaScript is able to manipulate the DOM tree, so the internal structure, how the web page is displayed, and is able to insert new elements in the DOM tree. So JavaScript is able to insert new images in the DOM tree, new script tags, new iframe tags. And so by this action, JavaScript causes HTTP requests. The main problem is that the targets of those requests that are created this way by dynamically including image tags, script tags, iframes are not restricted by the same origin policy, because image tags are not restricted by the same origin policy, because image tags were there before we had the same origin policy in the first place. So this way, JavaScript is able to do indirect communication to cross-domain hosts. And it can present some outgoing data through the URL, and it also can get some incoming data, which is rather surprisingly through side effects of the inclusion process. And especially this part will be the topic of the second half of this presentation. I'll start with this one because this is kind of cool too. And yeah, those are the three phases of cross-site request forgery that we will talk about in the next half hour. So the most common or the best known way of cross-site request forgery is exploiting existing applications. And again, I have to do 1 or 2 slides for background information so that we are all on the same page. And first I have to talk about an authentication in the application. The main problem is that HTTP doesn't have a session concept. We have one HTTP request, we get back one HTTP response. Okay, everything is done. For the web browser, it doesn't care anymore. The web server, it's complete. If you want to have something meaningful with authentication, the web server needs some way of knowing, okay, this user has been here before, I've seen his password. And so the web application itself and the web browser in conjunction have to do some authentication tracking that is not part of the HTTP protocol. There are various methods to do so. We did a classification at our university, and you can have a rather coarse classification that really is good for understanding cross-site request forgery. You can have explicit authentication, implicit authentication. And while explicit authentication is not really interesting in this context, implicit authentication is a problem. Implicit authentication denotes all authentication tracking mechanisms where the web browser is taking care of communicating the session identifier or the authentication credential without further interaction by the user and without further explicit actions by the web application. So methods in this class are cookies, HTTP authentication, client-side SSL. And if you look at that, those are the 3 dominating ways to do authentication tracking in web application. You can do it explicitly with a URL rewriting, which is broken by design, or form-based, which creates a really, really horrible user experience. So nobody uses those exclusively. I think about 99.99% of all applications use cookies. And therefore, next slide, really short, how do you do authentication tracking with cookies? I bet everybody here knows that. So you have the initial login request by the user, posting his username password to logging CGI. The web server says, yeah, this is Martin, I know him, his password is correct. And the web server sets a cookie, the authenticator cookie. This is, in fact, as far as the web server is concerned, this is the identity of the user. So with this step, this authenticator cookie becomes my identity. Now, every other further request that is going out from my web browser to the web server, to the domain of the web server, receives this cookie value automatically. So my web browser sees, okay, Martin wants to do some more further action with his bank, because I logged in here at my bank. Another request to my bank, my browser puts the cookies there automatically. So the web application doesn't have to care about this, and all they had to do was setting the cookie. And I don't have to do anything, all is done by the browser. And this is the cause of the problem. So the same origin policy should prevent cross-domain write access. And with write access, in this context, I mean causing stateful actions on web applications. Yeah, and this is cross-site request forgery in its purest form, or the way it was documented years ago. So what cross-site request forgery is doing is it's creating hidden cross-domain requests inside the browser without the user's consent or knowledge. And as we are using implicit authentication, these requests are automatically outfitted with the user's credentials. The attack, I have a nice example. So this is me, this is my browser, and I want to do some banking with my bank. And so I say, hi, I'm Martin, my password is foo. The bank says, hi, Martin, here's your authenticator cookie. And now I can go on and do as much banking as I want to, because the cookie is attached to all my further requests that go to bank.com. Now, while I'm doing my banking, I get a new email and somebody is telling me about the cutest cat he's ever seen, and I'm mad about cats, so I go to the page. And so I stop my banking, obviously, and I look at the cat. And the cat is fantastic. It's a web page served from attacker.org. What I don't see is that next to the cat, there's a hidden element. Might be an iframe, might be an image. I can't see it, I only see the cat. But this hidden element is referencing URL for my bank. And it's not referencing any URL, it's referencing the transfer CGI and tries to transfer a couple of euros to some interesting offshore bank account. And if my bank didn't know about Cross Site Request Forgery and didn't use pins and tons and stuff, or pins they could use, because pins is the password, but if there's no TAN mechanism, also no two-factor authentication, then I lost a couple of euros. This is actually the whole attack, and it's rather simple, but it's also rather effective. So what is really caused? The vulnerable web applications don't verify that state-changing requests are really created through interaction with pages of the application itself. So they don't really make sure, okay, Martin's sending this money because in the first place I gave him the HTML formula to give in the amount details and the whatever information that is needed for this action. They just accept, okay, this is the request, he wants to do something, I will do it. You can forge GET requests and POST requests as much as you like, so there's no magic bullet in this direction. And still, so Cross Site Request Forgery is getting some traction, but for example, in 2006, nobody really cared. So I looked up some numbers by when I did the proposal for this talk, and in the CWE project for 2006, they counted over 1,000 cross-site scripting issues that were reported through bug track, full disclosure, whatever. In the same time frame, they only reported 5 cross-site request forgeries. And the question is, why did they do this? A, are websites not really vulnerable? They are, I will show you in a minute. Or B, is cross-site request forgery actually not that bad? Are the capabilities of the attacker not that big? And I hope I will convince you that they can be big, depending on the situation. So I have 3 examples of previously found, reported, and fixed cross-site request forgery problems. We start rather easy. So who of you knows Dick? Okay, one. So Dick is something like Slashdot only with democracy. So the users are able to submit some stories to Dick, and they are buried somewhere in the system. And if a user of Dick likes this story, he digs it. So he says, okay, I vote for this story. And the more votes the story gets, the ranks increases, and it is more likely to be seen by the users. And really high-ranked stories end up on the front page of Dick. So Dick didn't protect the interface against cross-site request forgery. So somebody made a page where he wrote something about cross-site request forgery and included a cross-site request forgery attack to Dick that digged this page. So he submitted this. The first Dick user looked at this. While he was looking at this, he involuntarily digged the page. So there are already 2 votes. Then the next one looked at this, and so every logged-in Dick user digged this page if you wanted or not. And I think the page was the most digged page of all time in like 3 hours, stuff like that. So this is not a really big problem, you say, because it's just no real harm is done. For Dick, this is a big problem. The only value that the Dick application, the Dick website has is the trust of the users in the model, so that everything they see at the page was voted by the community. And if there's a way to subvert the community, the only value Dick has is gone. So this is pretty much the worst thing that could happen to Dick. And if somebody else did this, and not somebody that says on the page, hey, if you look at this, you already digged this. So it was really, really obvious. If somebody else that wanted to spam Dick with like Viagra or online casino advertising, it would be worse. It would have been worse. The next thing I really liked is, so people only get started to pay attention when money is involved. And so this was something that was discussed somewhere in 2006. Netflix. Netflix was an application provider, or it was like a video rental place. So you could rent DVDs online, and they were sent to you, and when you send them back, they sent you a new one. So you have a rental queue. And all through the web browser. So Netflix wasn't protecting against Cross Site Request Forgery. So an attacker was able to add some movies to your rental queue. So you decided you really want to see Shrek 2. It's a good movie. And he was able to put this movie at top of your queue. So he said, okay, you really should watch Shrek 2. And so the next movie you get is Shrek 2. And then he changed your name and address and said, okay, you are now living at my apartment. And now he's getting the DVD. And he also could take over address and email and the password. And he could overtake your complete account with Cross Site Request Forgery. So this was kind of ugly. And this is a hacker conference. So really interesting is owning other hosts. So this was an issue that I found when I started to learn about Cross Site Request Forgery. So WordPress is a rather popular blogging software. And WordPress was also not really protected against Cross Site Request Forgery. And every WordPress blog looks different because they have themes. And if you look at the themes, then you see the themes are actually executable PHP files. And you could edit these themes with your web browser in your WordPress admin panel. And this admin panel obviously was not protected against Cross Site Request Forgery. So with one single Cross Site Request Forgery attack, the attacker was able to insert arbitrary PHP code into the weblog, and therefore owning at least the web server as far as the rights of the web server user goes. So that was also a fun exploit. And doing Cross Site Request Forgery is really, really easy, and I will convince you. And so we come now to the 0 day of the day. I hope it works. I have a live demo. A student of mine wrote a small Python script. It's about like one page that makes writing or creating a Cross Site Request Forgery attacks rather simple. So it takes like 10 seconds. Okay, let's go. So we even have a little web page explaining everything and a little bookmark. And I put the bookmark in my browser. And then I want to exploit, for example, I took a local application. This is Soup. I think it was created somewhere here in Vienna. And so first I have to log in, obviously, otherwise it wouldn't make sense. So I hope I remember my password. Okay, I'm logged in. So if I want to create, obviously every Cross Site Request Forgery attack has to be tailored to some request target. And so usually you would go to the web application, look at all the forms and see what you can do. And this is what our little tool does automatically. So for example, if I want to create a Cross Site Request Forgery attack for the post interface, I just press the bookmarklet, which is really, really simple. Okay. And all the bookmarklet does is it looks through the DOM tree and identifies HTML forms. And the other action it does is that it changes the action of the HTML form, that it doesn't point to Soup anymore. Now it points to our exploit-o-mart script. And when I press save, I'm redirected to exploit-o-mart, and I can just, this is already really, really nice. I only have to go to a shell and pass it here. And now I have my exploit HTML, my index HTML. Okay, let's go back to my Soup. Okay, there's nothing there. But if I visit now the exploit page that I just created, that's hosted here, I only see the beautiful cat that I showed you before. But if I do a reload on my Soup, and if the attackers they're supposed. I didn't do anything on, so it was done by Cross Site Request Forgery. I hope this was kind of clear what I was doing. If not, come to me later. It's amazingly simple. Okay, yeah, and we can have a lot of profit this way. So this was, yeah. Okay, how do you avoid that? And this is kind of, it's not really tricky, but the interesting part is if you go to the Bible, to the library and get an HTML book, or even a PHP book, or any book that tells you how to write web application, you won't find a single book that tells you how to do it right, because they say, okay, you have an HTML form, it goes to an action, everything. So one can argue that cross-site request vulnerabilities are not really caused by programming mistakes. There are rather problems in the protocol itself. So if we want to prevent cross-site request forgery, we have to improve HTTP manually. How do we do this? We have to ensure that all our state changing requests live within our web application. There are actually 3 methods you can do this. You could switch to explicit authentication completely. You can do URL rewriting, so including your session identifier and URL. I wouldn't recommend that because there are other issues like session identifier leakage and referral logs and stuff like that. So you don't want to do this exclusively. You can try to find a framework that allows you to combine implicit and explicit authentication. I'm not aware of a free one that is there right now. I think Microsoft is starting doing something like that. Or you can start using nonces, and this is what you should do if you don't do anything else. So for every form or for every HTML page that is doing something meaningful to your web application, you should include a one-time identifier that is exclusively for this user, for this session, and for this form only. And only if this nonce is sent back to the application, then the state changing action should be done. It's simple, but it's totally tedious. So it's no big fun doing something like that, but you have to. Good. This was phase 1. The second phase is not, I think it's a fun aspect of cross-site request forgery because it's so Web 2.0. So we didn't have this problem like 2 years ago. And so this is what I like about this. Who of you does know JSON? So JavaScript, I don't even know what its object. Yes, thank you for coming. So JSON is, so JavaScript doesn't have a serialize function as Java, for example, has. And so JSON is a poor man's way of formulating or putting JavaScript objects into strings. And why do we need this? So all our new Web 2.0 applications, they don't do page reloads anymore. What we do is we click on a button and our page doesn't reload, but in the background there's some data exchange. And most modern applications do data exchange through JSON or comparable formats. So they say, I do something or give me some information, and the web application sends some data in JSON. And the interesting thing, and also what I don't understand, what is so stupid to do something like in 2004, is JSON is actually executable JavaScript code. And if we have learned something in the back of in like 20 years of computer security, that we should try to separate data from code. And these people are, okay, we invent a data format that actually is code. So come on, this has to go wrong somewhere. Okay, how is it done more precisely? So the web server says to the web application, okay, give me some data, for example, the address book of my email client. This could be done via XML HTTP request, for example. The web application answers with the data encoded in executable code, and the application is doing an eval on this data. That's totally horrible. There's an alternative. You could also do it with script tags. This is a variant you see sometimes. There are a couple of different formats. The most easiest one, and the first that was there was an array format. It's displayed here. But you can have also the JSON object format, and there are 2 variants that support browsers that don't have HTTP request, XML HTTP request, variable setter and callback function. And yeah, how does the exploit look like? As I told you before, the script tag doesn't have same origin policy restrictions. So from attacker.org, we can do a script tag to the webapplication.com. And as JSON in most variants is executable code, when you do something like that, the code is then executed in the context or the security context of the attacker's web page. So again, our attack. Now we are on a fancy page that is doing some web.2.0 magic. And we're doing our authentication and looking at our email, for example. And then somebody else tells us again about this beautiful cat. So we go to the cat page. And again, we have the hidden element that is doing the request. But now, the hidden element doesn't try to do anything state changing at the fancy.com web server. It tries to get some information. So this URL is loaded into a script tag. The data is returned. It's now executed in the security context of the attacker.org. So JavaScript that was brought by attacker.org is now able to access those information and bring those back to attacker.org. Depending on which format the JSON is, okay, that will be fun. Depending on which we have different ways of exploiting that. I don't go there into detail. I think you got the general concept. A nice example is the first public disclosed example was Google Mail. And so I think if Google is doing this wrongly, many other people are too. So the Google address book was communicated in JSON in the classic array format, and could be read by anybody just by this script. Consider if the user was logged into his Gmail account, and as you all know, it's rather hard to get logged out of your Gmail account. So it was a rather no-brainer exploit. So what is the defense? You always should make sure that your data is not executable. This is rather easy. The most recent, JSON object notation is not vulnerable, but I don't guarantee that your framework is using that one. Also, there are a couple of other recommended techniques. You could start your JSON data with a while loop that is removed before accessing the data, or you can do some other stuff. But still, maybe you should just use XML for data exchange and not JSON. It's not a good idea. Okay. Rather quickly, the third phase of Cross Site Request Forgery, one that was rather hyped, I think now a year ago, late 2006, Jeremiah Grossman and Robert Hansen came out with this at Black Hat. The same origin policy should prevent cross-domain data retrieval, right? Somehow. But we have something that we call the basic Reconnaissance attack. It's a really easy action to obtain the information if an entity that is hosted on a certain URL actually exists or not. How is this done? The JavaScript includes, for example, an image tag or something else that could be outfitted with event handlers, and uses 3 different event handlers to find out if the inclusion attempt has succeeded. So it uses the onload, the on error, and the timeout event. So the script loads an image with the URL something, and if the URL really hosted an image, the onload event handler will trigger. If there was a server that answered with some garbage data, this is no image, therefore there will be an on error event. If there's no server at all, the timeout event occurs, and so we know, okay, there isn't even a web server at this point. How can we use this? Again, I talked about implicit authentication, and one of the implicit authentication classes I didn't mention is what we call IP-based authentication. You can find this in every single company. You have the perimeter, this is firewall, and you have some intranet web servers, and every web browser that is inside the intranet is implicitly allowed and authorized to access the internet web server. Everybody that is outside the firewall is not allowed. As Cross Site Request Forgery subverts implicit authentication, the firewall is also vulnerable to Cross Site Request Forgery. It's rather easy. We have the request for the cat picture, and now the cat picture brings a little guest that references intranet resources. So if you put this together, we have the basic Reconnaissance attack to find out what is hosted in the intranet, and we have the Cross Site Request Forgery attack to do something meaningful. The attacker is actually rather powerful. So to make it more clear, so the malicious host here wants to know if there is a server at some private IP that he hasn't been able to access because of the firewall. So it sends this Cross Site Request Forgery payload. And the Cross Site Request Forgery payload now tries to access an image that is supposedly hosted at 10.10.10.10. Depending on, as I told you, if there's actually a server or not, a different event triggers. Usually the on-error event would trigger if there is a server, because this is really fast. If the request goes into nothing, then there's a timeout event. And this information is sent back to the attacker. Okay, but this is not a really biggie. So this is not Cross Site Request Forgery, but it's rather important as well. So all my hosts are netted, and I use some rather obscure 10. Whatever IPs. So the IP space the attacker has to scan through is so big, I'm rather safe, people say. We don't have not only have JavaScript in our web browsers, we also have Java. And Java is something nice. Java has a socket object. And the socket object allows us to do socket connections from the website in the browser back to the host. And the socket object gives us information about the local IP. So if your company allows you to execute JavaScript, execute Java applets, then your IPs are not really that secret to the outside. Okay, what can we do, or what can the attacker do? At first he would do a ping or HTTP sweep through the intranet and see which IPs actually are hosting servers. After he found the servers, he could do a fingerprinting attack. I'm not sure here. A fingerprinting attack to load websites from the servers and try to find out what is actually hosted there. So depending on what you do there is you use unique URLs. So every single web application has a unique URL that is not shared by anyone. You have PHP Easter eggs to find out which PHP version is running on the web server. You can find out if you have Apache or IIS, because they all bring like documentation stuff that is rarely ever removed, especially in the intranet context. And you can do this really easily, especially with Firefox browsers, because you have access to the error console that gives you even more information. This is rather easy and nice to do. There are some other problems. You might encounter HTTP authentication, which pops up then, because all you're doing, or all the attacker is doing, is executed in the web browser of somebody that doesn't know what's going on. And so he wants to be stealth. And if he encounters an intranet host that is protected by HTTP authentication, nice, viewable dialog will pop up to say, give me a password or anything. But Stefan Esser, that he's here at the conference, but not in this room, I think, found a couple of nice techniques to get around this. The main technique is, okay, you send requests to the web application, but those requests are not completely valid. And therefore, the web server sees, okay, there's something, gets back an error message, but he never goes to the point where the web server itself finds out, okay, I should have demanded authentication. So this is a really nice trick. What can he do? So he can locate intranet hosts rather easily. He can fingerprint the applications, and now he has a nice list of promising points for cross-site request forgery attacks. So with home users, something that I think almost always happens is that you can change default passwords. You can use default passwords on home routers, because the home router only listens to the internal interface, and only the owner and maybe his wife and his kids have access to the interface. So why do you want to change the password? So I bet with you like 99% of all home routers have still the default passwords. Mine had before I did this investigation. And then you can, for example, change the DNS settings, put in your own DNS server and route all the victims' traffic through your internal stuff to do pharming attacks or whatever. In the company context, it's interesting because you will find some unpatched servers that live in the basement and host some obscure intranet application or some old school WordPress. Why would I want to, if I use WordPress in my company to do some internal communication, why would I patch that? There's no real reason. And if you take DNS rebinding, which what I'm not talking about today, into the account, if you know what this means, then you get full read and write access to those servers, and then things get really, really interesting for the attacker. But this is a different talk, and I'm almost finished already. Okay, there are some limitations. So the attacker has to work with timeout events, and timeout events take time. So a good technique would, for example, to have the victim to look at some videos. Videos are rather interesting, so not a cat picture, so cat video would something that I would try to host if I would attack somebody. You can try, or he can try to paralyze, so not requesting one image at a time, but like 100. Most web browsers, and especially Windows XP and Windows Vista, set limitations on the number of parallel connections that are open. So this speeds up the attack somewhat, but not totally. And also, you only can, or the attacker only can access certain ports, which is enforced by most browsers. Okay, countermeasures. This is basically 2 slides to tell you what I'm actually doing. I'm not investigating those vulnerabilities. Usually, I try to fix those, and we've built at our university 2 countermeasures. Both take effect in a web browser, so we built 2 browser extensions to protect against attacks that try to exploit applications. We built an extension that drops all implicit authentication information from cross-domain requests, which is rather unobtrusive and works. And the other one, this is RequestRodeo. The other one we built was LocalRodeo. This protects the intranet against the Reconnaissance attacks. We do the segmentation between a local and remote IPs, and if a web page that came from a remote IP tries to access a local IP, the request is dropped. So it's not that hard to fix the situation, but right now we still have the problem. If you're interested in that stuff, this is my website, databasement.net, and /CSRF or Cross Site Request Forgery. You'll find links to further documents, presentations, and to the source code of our stuff. To be complete, there are also a couple of other people working on this topic. OWASP just recently started to pay a lot of attention to Cross Site Request Forgery. They have a tool, CSRF Guard, that is J2E based and should protect the applications in a transparent measure. And the TU Vienna, so people from maybe somebody of those people is already here. They have a nice academic paper on server-side countermeasures. I haven't tried both of them, so I can't tell you if they work or no. But they definitely are nice ideas. Okay, that was it. Thank you. And the first question.
Does this mean that it's possible to maybe include a local file in an image tag that is included? Maybe the etc hosts file or something?
Yeah, you could.
And then go by JavaScript over the DOM tree, pass that data.
No, you can't do that.
You can't do that.
It was possible to find out if certain files exist on the host. I think this is fixed with most browsers now, so file URLs don't trigger events anymore. But I'm not too sure about that. You should try this. It was possible a while ago, but I think it isn't possible anymore.
You can still discover which disks exist on a system.
Yeah, there's like there was numerous blog posts. Everybody tried to find out something. If you're interested, I'll give you my email address. I wrote a paper for the Springer Journal of Biology, which sums up everything that was written in this. But yeah, so it was a nice research. Somebody else?
Question to the DNS rebinding.
Yes.
Does it work because the policy is port protocol and domain instead of IP address?
Yes, totally. So
will there be any changes, maybe that the switch to IP address instead of domain?
there are good reasons why you don't want to put all the your security context completely to the IP, because you have like sessions that last forever, and you have something like load balancing or other problems. And also you have situations where users can't do security decisions on an IP basis at all. So all big companies have like outgoing proxy servers. So then from those, it appears that if all the applications are hosted on the same IP address. So the IP address is an address and shouldn't be used as a security feature. I think one of the things we learned in the last 20 years of security is if something wasn't designed to be a security feature, don't use it as a security feature. It will never work completely. So you have to think hard about, so cookies, using cookies for authentication tracking is like awful. You shouldn't do this.
Same as DNS.
Yeah, totally. Using DNS for the same origin policy is one of the worst mistakes ever made by web applications. And we have to get rid of the same origin policy tomorrow. If everybody, I think, agrees. Okay, so much about the preaching part of this talk. Okay, then, thank you.